new project. It's very eccentric, and I look forward to your reactions. In his exhibition, Particular Matters, the Berlin-based Brazilian artist Thomas Saraceno, I hope I'm pronouncing that correctly, reserves one of his spaces for producing a situation of complete darkness for his visitors, which he illuminates from one side by means of a single light source. The result is that the visitor, upon entering the space, sees a sharply delineated cone of light. The site occupied by light is otherwise empty, but as the visitor approaches it in the darkness, the cone of light appears filled with clouds of stuff in the air, for want of a better term, that the projected light touches and scatters away from. A collaboration with the Columbia School of Climate, like much of Saraceno's work, particular work about air, Particular Matters is dedicated to the forces, the elements, and the dynamics constituting the substance of the air that we walk around in. The particular matters forming air reveal themselves here as particulate matter, in whose particular constitution Saraceno is interested. We are met with a swirl of skin flakes, textile fibers, hair fragments, insect wings, and pet dander. The air sometimes also reveals the water vapor and tiny droplets that constitute it, or depending on the season, pollen grains, bacteria, and fungal spores. Shown in urban and industrial contexts, the piece also introduces visible smoke and soot particles. But even without knowing what it is, seeing how much stuff there is in the air is enough to make you want to cover your mouth and nose as you breathe. This piece could be understood as a metaphor for our post-Anthropocene condition, meaning that the task of the visitor is not to understand. Instead, it is to realize that whether we understand it or not, we as humans contribute to and participate in the complex migration of matter across the world and indeed beyond. It is too complex to be mapped. But as Saraceno shows in quite visible terms, this migration of matter can still be experienced. In fact, if one takes into account the skin flakes being actively shed by the observing body of the visitor, one might say that the observed phenomenon is an epiphenomenon of the observer's experience, without whom it would not exist in this particular configuration. Another version of this kind of performative riddle, oh, I'm sorry, the tab came back, but I don't know how to get rid of it. It'll be fine. So another version of this kind of riddle is Anthony McCall's 1973 Line Describing a Cone, which is a 30-minute film that develops from a single point projected from one end of the room to another to a circle, which then forms into a cone, during which the atmosphere of the room thickens, simply because in 1973 McCall was banking on every single visitor lighting up a cigarette, at least one, meaning that by the end of the 30-minute piece, the beam, this cone, takes the form of a solid light sculpture. What both of these pieces have in common is firstly creating a sense of separation from the dimensions or scale at which we visitors observe our environments normally, an effect of an out-of-body experience created through this enclosed and artificially darkened space. But it is also a sense of an enhanced point of view on reality, almost as though we were occupying an anechoic chamber designed to isolate and amplify information in a single acoustic wavelength. Here, sound frequencies being swapped out for light waves. It is remarkably effective at both acknowledging the observer and profoundly alienating the observer. In stepping into particularly Saraceno's piece, there is an increasingly uncomfortable sense of density and closeness to the matter that appears repellent and unnatural. There is no stopping yourself from breathing in this particulate matter, that is being made visible. With every breath, we watch ourselves renouncing, denying this protective envelope that we had imagined our bodies to have provided us. The piece becomes one about our fundamental permeability and extension into the surrounding atmosphere, into which we dissolve, despite our best attempts to refrain from breathing. From the viewpoint of experimental observational systems, these installations demonstrate our predicament as humans to become entangled in systems that are larger than us, impenetrable by us, but also observable to us. This paper is going to be about the type of darkness associated with the condition of being very small or being supermassive. The supermassive sounds like a colloquial, or I will go back. Sorry, I wanted to show you. This is Saraceno himself, who's wearing a mask. The supermassive, it sounds like it's like a colloquial term to mean very large or very big, but actually it is a technical term, and it dates from the 1950s and 1960s to describe astronomical objects that are, yes, very large, but also importantly compact. And the term compact refers to the mass or material density of the astral body. The supermassive is an astral body that would be many orders of magnitude greater than that of a typical star or stellar remnant. The supermassive specifically refers to this mass range between 10 to the 5th and 10 to the 10th solar masses, which means essentially millions to billions times the mass of the sun. Put differently, the supermassive is the equivalent to the mass of a black hole. A black hole being a celestial entity whose gravitational pull makes it the most dense material in the universe. And here I want to show you this clip. I think I can find it. Thank you. Now I hope. Oh no. Is it VLC? Because
it's below.
we determined that it should be. No. Oh, you prepared it. Thank you so much. Okay. The sound is a bit quiet. It's only 1 minute long.
Oh boy. What is a black hole? It is so deep. It's so hard to fully appreciate all of the physics that's going on. You can spend your life studying this. Imagine an object where gravity has become so strong, it has compressed all of the material with which it started down into a point. This object develops what's called an event horizon. This event horizon has this amazing property that it's a one-way street. You can go from the outside to the inside, nothing will ever get out.
The gravitational pull is so strong that anything that comes close enough to it will just vanish inside. If something disappears over the event horizon, it's gone, and we no longer have any knowledge of it. It is no longer detectable, it's no longer knowable. It might still exist, it might not still exist, we have no way to know it. We have a
So I will show you. This is our project. You can soon start visiting the website. It is still under construction, but our hypothesis in this project is the following. Although the supermassive refers specifically to the behavior of an outer space entity far, far away, namely a black hole, it might be able to gain us insight into a tendency we have down here on Earth to build spaces that exhibit observational effects arguably similar to black holes, namely black boxes. Black boxes today commonly refer to technical devices whose inner functioning is not accessible to the user and whose use involves interacting with either the information they are receiving as inputs or that they are emitting as outputs. The most common black box today might be the computer, which most individuals are capable of using at great degrees of precision and efficiency, despite having little to no understanding of how they actually work. Black boxes have a history that is much older than computers, older perhaps than the concept of information, being perhaps most closely aligned with the history of experimental observational apparatuses and the mysterious powers of bearing witness. Oh, this is a demonstration, sorry. Some of the earliest drawings of astronomical phenomena were produced through simple dark chambers. Called by their Latin description camera obscuras, these operated on the principle of sensory deprivation, very similar to the anechoic chamber, allowing light and the information that it carries to pass through a single tiny puncture in an otherwise completely sealed room. You can see demonstrations. As the media historian Jonathan Crary has argued, the camera obscura, as found in the treatise Optics by the physicist Isaac Newton, was not just a model for empirical observation, but also one for self-observation. In optics, Newton describes himself not as an observer, but an organizer, a stager of an apparatus from whose actual functioning he remains distinct. This dark chamber is a model of the mind of the astronomer, which turns away from the direct observation of nature, not trusting their senses. As with Vermeer's 1686 The astronomer is isolated in a darkened room and turns away from the exterior world that would meet his eye through the window. Knowledge about the world is conditional on withdrawing into inner contemplation, a kind of inner vision that is illuminated by the light of reason, not the light of the sun and the stars. The second black box technology of knowledge generation I will look at involves quantum mechanics and its system of observation, whose discovery or invention is traditionally dated to exactly 1 century ago with this paper in 1925 when Werner Heisenberg published an article that would disrupt classical physics. What is classical physics? This is understood as physical systems described as having definite properties and that can unfold in a continuous and predictable way. With regard to the classical evolution of a physical system, quantum mechanics fundamentally changes this picture. The mathematical formalism of quantum mechanics has allowed us to make numerous predictions which have been extensively tested and implemented in everyday technologies. For instance, solar panels, GPS systems, USB drives, LEDs, basically anything with a superconductor. But it is fair to say that from a conceptual point of view, its laws can be best described as a black box. The reason for this stems from the distinction that the quantum mechanical laws make between the physical system with its quantum evolution and the measuring device, which is the observer. The theory, however, is in no way describes what is happening with the system between its initial conditions and the final measurement. Indeed, quantum theory provides a complete mathematical framework for predicting observable outcomes, but remains silent about the underlying process that connects them. In this sense, a quantum system behaves like a black box. We specify the inputs, how we prepare an experiment, and record the outputs, what we measure, but we do not, and perhaps cannot, know what occurs inside. A simple example of this is the Schrödinger's cat experiment. The cat is in a superposition of being dead and alive inside of the box. Say that quantum mechanics predicts that it has a 50% chance of being alive and a 50% chance of being dead. Only when you open the box does the system decide in which of the two states the cat is. It is either dead or alive, but only after it has been measured or observed. However, it should not be forgotten that the laws of quantum mechanics are deterministic and that the evolution of the probabilities is deterministic. The only indeterminism comes into play at the point of measurement. To do justice to the many conceptual crossovers between physics and the history of media and art, which are actually tangible in the latter's appropriation of the term black boxes, which appeared in the work of a physicist, called David Bohm, I will start drawing on the writings of this physicist turned philosopher, Karen Barad, and her concept of agential realism, as she develops this in Meeting the Universe Halfway, her 2007 book. Agential realism combines insights from quantum physics, feminist theory, and science studies to propose an onto-epistemological framework, one in which knowing and being are not separate activities, but entangled processes. For Barad, reality is not composed of independent objects with pre-existing properties, but of phenomena and dynamic events in which the boundaries between subject and object, observer and observed, are actively produced, or put differently, performed. What we are proposing is that while performance is primarily associated with art and visual culture, there's an important sense in which this concept of performativity may also apply to the observation of scientific or specifically physical phenomena, particularly as these involve the observation of entities at a very small or very large scale. At the heart of agential realism lies the concept of intra-action. Unlike interaction, which presumes the prior existence of separate entities that later relate to one another, intra-action means that the entities emerge through their relations. Measurement, then, is not a passive active observation, but a material discursive event that enacts a particular reality. The world is not given, but continually constituted through these intra-active practices, almost like performativity. This view is deeply inspired, by the way, by the quantum physicist Niels Bohr, who insisted that the experimental apparatus, so the apparatus itself, and the object of study cannot be meaningfully separated. The third system, this is the last system, returns us to where we started, inside of a black box, in this case being a black hole. Particularly the black hole that was one of the first to be photographed in the galaxy M87. This is not our galaxy. In physics, as in information theory, a black hole functions as a black box in that its internal states are inaccessible to external observation. Only its mass, charge, and angular momentum can be measured from the outside, and it's called the boundary of the black hole is called the event horizon. So you have to be outside. Inputs, matter and radiation, are transformed into outputs, but the mapping between the two, the input and the output, remains opaque, with two types of information being emitted: gravitational effects and what is called Hawking radiation, not corresponding in any simple way to the information content of the matter that formed the black hole. So information went in, and then the information that comes out seems to be scrambled. Yet, as Karen Barad's notion of intra-action suggests, the observer and the observed are not independent entities, but mutually constituted through measurement. In this sense, the black hole, as a black box, is not merely hidden, but ontologically entangled with the apparatus and the conditions of observation. In conclusion, such types of system could raise questions about what makes the observer such an important component of physics, or indeed, what is the observer in the first place? A topic that is open to debate across the arts and sciences. Just as Saraceno's illuminated darkness renders visible the particular traces that constitute our shared atmosphere, these other black box systems, whether quantum, technological, or cosmic, remind us that every active observation is itself a performance in which the observer becomes part of the scene.